Moving on to question 2, we have another electrolysis question here. Now this situation is when you have two electrolytic cells connected in a series to a power supply. So that's a negative and that's a positive. Okay, when you have something like that, I think I'm going to go back to your SAC and actually put the negative in. It's a bit unfair to expect you to know that. You just treat these two cells as separate cells, and the only thing they really have in common is they share a power supply. But the charge is going to go into the negative, get sucked away from the positive, into another negative, sucked away from the positive. So you can identify the cathode and anode for each electrolytic cell. Cell 1 consists of copper nitrate aqueous solutions and copper electrodes. Cell 2 consists of an unknown metal nitrate solution and the electrodes made of the same unknown metal. So you are actually provided with the charge of this metal ions, which from here you know that that's wrong. From here you know that X has a charge of 1 plus. Okay, in 31.0 minutes, 0.0949 grams of copper. So when time is 31 minutes, 0.0949 grams of copper is deposited at on electrode A. In the same time, 0.322 gram of metal is deposited on electrode C. Now that C is not it's not carbon, it's just a letter. Hopefully that's not going to be too confusing. Right, calculate the number of Faradays of charge transfer while copper is being deposited in cell 1. Right, okay, I need to work out the number of Faraday. The number of Faradays of charge is actually equivalent to the number of electrons being supplied, and in order to do that, all you really need to do is to work out the number of mole of copper and then use the mole ratio. So I'm going to find N of copper, which is mass divided by molar mass, 0.0949 divided by 63.5, which is 0.00149 mole. And always write the half equation so that you actually get the number of mole correctly. So number of mole of electrons is going to be twice the number of mole of copper. Let's try again. Okay, which is 0.00299. 368, yep. 0.00299 mole. So that means that you need 0.00299 Faradays. So that's the answer to the first question. The first mark is a method mark, which is going to be awarded for correct number of mole of copper, and the final answer. That's your 2 marks. Moving on to part B, determine the identity of the metal. Now, if you want to work out the identity of anything, you need to have the molar mass of that thing. And you already know that X is X plus. So I can tell from here that the half equation is X plus plus electrons going to X. I know that the number of electron is, the number of mole of electron is 0.00299 mole. And because of a 1-to-1 mole ratio, that is going to equal to the number of mole of X. You also know from the question that this many mole of X, it has this mass. Now, one of the biggest assumptions we're making right here is that the amount of electrons going through cell 1 is the same as the amount of electrons going through cell 2. And this is a correct assumption, considering how the two cells are being connected on the same power supply. So that's a fine assumption to make. So I'm going to divide mass divided by number of mole. Let's see what we have. 0.322 divided by that. I got 107.7 gram per mole, which I think is most likely to be, I have an idea what this is supposed to be. Let me just delete that. I think it's gonna be silver. Silver is 107.9. Hang on. Yes, I think that's close enough. So M is silver. And it makes sense. It is silver is an one positive ion in its ionic form anyway. I think that's the end of question 2.